Hi, ME228. This is Kate. We're going to continue on with the part drawings. You really do need this for for your group project stuff. So I'm going to post this video. You're already seeing it on YouTube. And then the homework will still be due on Thursday at 9 a.m. So remember that I do have Monday and Wednesday office hours. So if you're struggling with this homework, come see me. Also, though, the first problem of your homework this week is one of the textbooks or one of the tutorials in your textbook. And I think it does a really nice job of walking you through part drawings. So we're going to start with some housekeeping stuff. I really need you to go to your one-on-one grading time. So I know that the Thursday and Friday people this week, so the 7th and 8th, have their one-on-one grading times canceled, but really, so it's so important that the Monday, Tuesday, and Wednesday people go. I can't express how much time we spend on these appointments, and it's so necessary that you are coming and not trying to reschedule. That creates a lot of extra work for us. And so I really need you to prioritize that one-on-one grading time. Your homework assignment is live. It is on Blackboard. We're going to keep that same due date. So now your homework 2 is due Monday the 11th at 9 a.m. and your homework 3 is due Thursday the 14th at 9 a.m. And just as a reminder, these slides, as long as all the other presentations, are posted on Blackboard. So you can find them, look at them, watch the videos over again, and please do that. So we're going to start today by talking about your drawing packets that you'll be doing for your group projects and kind of just some general housekeeping group project stuff. Then we're going to go into additive manufacturing, which is actually your homework 10. It's being assigned today. And we'll talk about part drawings, doing them in SolidWorks, and then we're going to go over dimensioning. Your hand-drawn stuff is going to be on dimensioning this week. And then finally, we're going to finish up with a couple new tools in SolidWorks, like circular patterns, mirroring, some things like that. So we keep throwing the term BOMs around, and I just want to make sure that you know that the BOM is an acronym for Bill of Materials. And so I'll show you an example. Also, one of the weakest parts, I think, of some of the presentations or the group discussion stuff I saw this week was probably our hypothesis. So I want to do a quick refresh on that. I'm going to show you an example of a drawing packet, and then we're just going to go into some general advice for the presentations. So let's start with the bill of materials. There's a lot of different ways that you can do this. I mean, the name explains it, but these can be very simple or very detailed. Now, SolidWorks, when you create an assembly, which means if you put a whole bunch of parts together and connect them, it will create a BOM for you. But that isn't really what we mean in terms of the context of this project. So what we're saying here is that we want to see every single part that you're going to put into your device. So if you've got 10 Phillips head screws that are going in, I want to see those listed. If you are using 3 8-inch, I don't know why you would do this, 2x4s, or you know, a 24 by 12-inch foam sheet. I mean, every single piece, your Arduino, your push buttons, everything. So breaking things down into their absolute simplest components. Now, you know, if you've got some things like maybe you're using a motor that's coming as one piece, you bought like a little step motor or something, you know, you don't need to break that down into its components. But anything that is being treated as a unit, you really need to have on your list. So some of the things that we'll want to see are part names, a description of that part, and you can do that. You can also do its function. You might do both. It kind of depends on how specific you need to be. Take a guess at the material it's made out of. You can be general. You could say plastic rather than maybe like ABS plastic. But really take an educated guess at what the material is made out of. Size, so do basic like length, width, height, dimensions, the number that you need, where you're getting it from. So maybe you're purchasing it, maybe you're scavenging it, maybe you own it, maybe you're, pulling it from a dumpster. You don't need to say you pulled it from a dumpster. You could just classify all those as like already own or recycled materials, things like that. But you do need to say where you're expecting to get each of these pieces, whether it be that we hand it to you, like the Arduino board, or if you're purchasing it yourself. And then finally, you need to figure out the cost. So if it is free to you, you already own it, or it's something that we're handing you, then you don't necessarily need to estimate that cost. You don't need to look into that. But anything that you're going to purchase, don't just take a guess at what it costs. Look it up, and look it up on somewhere that you're going to get it from. There are lots of places that things are available. But if what you're doing is ordering it off Amazon, then you need to look up the cost on Amazon. Does that make sense, hopefully? So the bill of materials needs to be pretty specific. And it needs to be complete. So don't take guesses at this. Really, how many screws do you need? How many are you going to use hot glue to put this together? Odds are some things will change, but the more detail you have, the more we know you've really thought through this process. The next thing that you'll have to do during your presentations is set up a project timeline. What I have seen in the past is that students will just list out the deadlines that we're giving you, like next week's a work week, the week after is expo. Like, I already know that. Don't tell me the deadlines that I've given you. We need you to be specific and set team internal deadlines for yourself, and they need to be listed in a logical way. So there's lots of ways to do this. We've got a Gantt chart here. You could do a weekly calendar. You could do a spreadsheet, sprint list. I mean, there are a lot of ways to skin this cat. But it needs to be specific, and it needs to not be like, finish the manufacturing. I want to see something more like, Jane is going to go purchase these materials and have them in our drawer by X date. We are going to have the Arduino wired by X. We're going to be collecting data by X point. We're going to have the prototype put together by X date, or we're going to have it completely manufactured by this date and then painted on this date. So do not tell me the deadlines I've already given you. I know them. I told them to you. Break it down further. Say who's going to be doing what. Really, plan this out. It'll be so helpful if you will give each other internal deadlines. But also, you're going to be given a grade based on if you've set a timeline together or not. So please do that. Really, one of the weaker parts of what I was seeing in discussion was your hypothesis formation. So remember we said, the past two projects, like last semester, we were really turning towards industry as kind of the format we were putting it together. This project is really a lot about academia. And one of the parts of this is this hypothesis formation. So I would guess this isn't your first time doing this, but maybe it is. So a good hypothesis, it needs to be clear. It's got to be a statement. And when you're first starting out, this if, then, due to format is actually a pretty good one to follow. You don't have to go that route. But honestly, if this is maybe your first, second, third time forming a hypothesis, just following that exact format is not a bad idea. So I'm going to walk you through this example of mine, and this is the stabby finger game. So I did see somewhere that it was called pin finger, which is interesting that it has a real name. But anyway, the idea is that you are stabbing a knife quickly between your fingers spread out as pictured here. So in this example, I have been given dexterity as my topic. And so what I'm thinking is that I want to see a connection between dexterity and physical exhaustion. And based on some articles that I've read, I think that being tired will decrease dexterity. So how I'm going to test this is I'm going to have half of the students that walk up just go straight for it, stab the knife between their fingers as fast as they can. And then the other half, I'm going to have them do 40 jumping jacks, and then they're going to stab the knife between their fingers as fast as they can. This is not a real example. This is very unsafe. We wouldn't do this, but I think you get the point. So I put my hypothesis in this if, then, due to format. And so my hypothesis is if students are given a physically demanding task, then it will take them longer to complete the knife game due to the physical activity reducing concentration. So use that format if you're getting lost, but be really specific with your hypothesis. So work through that. I saw a lot of teams that could really improve on that. Finally, I'd just like to talk about what a drawing packet is. So we're going to go over part drawings today, and that's essentially what's in your drawing packet. Not the week of Expo, but the week after, you'll be expected to turn in a complete drawing packet for your device that you create. And so I'm going to take you through an example from last year that has some really great drawing packets. So they had a strength and endurance, and they had this wheel of power, and it was spinning the wheel, and they had a rotary encoder, and how many times it spun around equaled the student was stronger. I don't remember what their hypothesis was. So every single part, so every rod, every board, everything got put into these part drawings. And this part drawing is what I'm going to show you how to do today. And so I want you to think about that. Next week, by next week, your deliverable says that you've made progress on your parts. They don't have to be in part drawings yet. You can just have the parts themselves catted. But eventually, this is what you're going to do. So you're just going to have a whole bunch of parts. So like, see, they've even got some of their LEDs. They've done the battery. They've done the wheel. Their screws, everything, every single entity is broken down into these parts. And then they come and show us assemblies. So we haven't talked about assemblies yet. We're going to get to that really soon. But you'll use those parts to come together. And that's part of why having parts be fully defined is going to be so important. As you're putting your assemblies together, it'll matter. And it'll also matter that you use the correct dimensions. I would suggest using parametric equations so you can pretty easily change a whole bunch of dimensions at once if you need to. That's why we're learning it kind of in this order. So I think this is a really good example of a drawing packet. This is actually not all of their part drawings, but it's a good majority of them. I think the other thing to point out too is that, these parts aren't overly complex shapes, and you can simplify the shape. I mean, they already had some pretty simple shapes anyway, but really break it down into its most primitive pieces. And I think what you'll find is that what we're asking you to CAD is not overly complex. I mean, this is just a circle with some holes cut out. This is definitely something you could probably have done without even having class by just, playing around in SolidWorks. So don't get overly concerned with the complexity of the shapes. Next task, homework 10. So we are assigning homework 10 today. It's kind of weird, I know. We'll talk about this again in class next week because there is some nuance to homework 10. but it is available. You can look through it. Homework 10 is focused on additive manufacturing, and it has you print your own CAD drawing on the Mojo printers that are in Learn at 1100. So step one, you complete the online tutorial. It's not really a tutorial, it's just got some slides, maybe like 10 slides, and then you take a quiz. So if you go into your Homework 10 folder right now, so the folder that looks like that, you should see like some how-tos, but also the only assignment will be this part 1 of 3, the pre-quiz. And you have to score a 6 out, you get one shot, and you have to score a 6 out of 7 to be able to submit the rest of your work. So that pre-quiz is important because what you're printing, it adds up to a lot of money. And so I want you to really understand what you're doing. We can't do a lot of redos. So I think that it's really important that you understand the constraints of the assignment. The next thing you do is CAD your SolidWorks part, save it as an STL. There's a document that shows you how to save a part as an STL. But essentially it's just click Save As and then change the part type to STL. You are going to upload your part to one of the computers next to the 3D printers. So next to the 3D printers, there are computers and sign-up sheets. There's also printouts that show you, that walk you through how to use those printers. It's not overly complicated. I feel really, there's like 10 steps and it walks you through with pictures. I feel like you're going to be able to look through that and be just fine. But you are going to go through this print wizard to figure out how much material your part will use and how long it will take to print. So for part 2 of the assignment, you submit the STL part, or yeah, the STL file, the SolidWorks part. So just that regular, that file that you've been submitting as homework, so that file as well as either a picture or a screen grab of that print wizard screen that's saying it's going to take X amount of material and X amount of time. There are these sign-up sheets that look like this next to the 3D printers, and you will sign up for a time slot. It cannot be more than 6 hours. And then you'll show up for that time slot, start your print, start your build. Once it's done, you'll come back so that somebody else does not do this for you or maybe mess up your part. You'll come back, put it in the fog machine to dissolve the support material. And then for the final part, so to get the rest of the points, you're going to take 3 pictures of your completed part and submit it on Blackboard. So as of today, these printer sign-up sheets are going up in Learn at 1100. So they just sit right next to each of the computers. You put your name, your email, and do put your email because then if like something goes weird with your print, I mean, I can look you up by your name and username, but maybe the next student behind you is like, and be like, oh, hey, buddy, your print is not working. So they can email you real fast and you could come back. Your username is so that we can tie, your username will happen because you'll log into the computer. And so then we want to be able to track who you are with your username. And we are not the only ones that use this computer or use these printers. So if you're doing this as part of Homework 10, your description or like purpose is just Homework 10. Maybe you're doing something for the project, you would just put projects, but also some senior design groups sometimes use those printers. So we just want to know why you're doing it. There are a lot of you, I'm not good. There are a lot of you, and the printing takes a long time. It just does. If you want a piece that's faster to print, if you'll make it flatter, it'll be faster. But we have to stagger the due dates. So it is kind of weird that it's Homework 10 when we're only on Homework 3 right this second, but each person in the team has a distinct due date. So it's up to you to look up your name and what your due date is. So it'll be due on a Thursday at 9 a.m., the same time as your regular homework. But each person really needs to look up. We are not accepting late work on this. So look up, mark it in your calendars. You can do this. Yeah, and we won't send out a reminder. It'll be up to you to know what your due date is. And you can do this early if you want. There's no reason or special, you could just get it done. I mean, you could start this week, and then even if your due date's May 2nd, you could just be done with it and not think about it. Okay, so now we're getting to the good stuff, part drawings. So if you'd like to follow along, which I'd really encourage, go to Blackboard and download this anchor base part. So it's up there, it's posted with the notes. You can download it, and that way you don't have to CAT it. I mean, you could take a moment and CAT it yourself, but it is up there if you'd like to just follow along quickly. So we use 2D drawings to communicate ideas about parts, about manufacturing process. A lot of times you're going to be using these 2D renderings rather than a 3D file. I think we could have a healthy discussion about whether that'll change and what the industry is moving to, but as it currently stands, you really need to be able to put together these 2D engineering drawings. So what I'd want you to do, follow along with me. You've got your part, it's open. You're going to go to New, and you're going to make drawing from part. It's like make drawing from part / assembly. And you're going to select Draw. And then hit OK. Depending on your computer, sometimes the on-campus tutorials, rather than immediately giving you the draw, it gives you a different screen. It shows you some different standard templates. For this moment, it doesn't really matter what you pick. Like an ANSI size B is probably pretty good. So look for something that says ANSI B. If all you're seeing is ISO, that's fine for this moment. We'll talk about that more later. So get your drawing sheet going. And this is what it'll look like. It'll be this blank sheet, and you'll have kind of these orthographic projections that come up on the side. So let's just take a second to orient ourselves in this drawing mode of SolidWorks. You'll notice it looks really similar to when you're creating those part files, right? You know, you've got that command manager on the top, you have your design tree, you have a view palette, which you have in the part drawings as well. If you look through kind of like view layout, annotation, sketch, evaluate, I mean, you're seeing a lot of the same things with some new, but that you were already familiar with from your part drawings. So there are lots of ways to set document properties. What we are going to ask is that text, like your dimensions on your parts, it needs to be legible. And we'll count points off for not making it legible. So knowing how to change these document settings is important. There's a couple of ways you can do it, but the way you can get to everything is by going to that little gear at the top, it's the settings button. You have choice between system options and document properties. So the first thing I do is I make the hidden lines visible. So go to display style and then select hidden lines visible. Next, I'm going to the document properties tab. And instead of the ISO standard that I went to automatically, I'm changing it to ANSI. If you picked an ANSI sheet, it's probably already there, and you can just leave it there. In that same tab, I'm going to units, and I'm going to make sure that it's set at inch pound seconds, so IPS. I can also set some sheet properties. So I'm going to right click and then select properties. I can change my scale, my sheet size. Ooh, look at this, type of projection, first or third. Who remembers that from last week? Quick quiz. If you click on each of those standards, you can see what they look like. So it looks like I set it to a size C, ANSI landscape. All right, so next I'm going to bring in the 3 standard views. Do a quick check. Do you remember what those are? We talked about them a lot last week. Yes, I'm sure you know what they are, at the top, front, right. So we'll use that a lot, not exclusively, but quite a bit. And so when I ask for 3 standard views, that's what I mean. So in your View Layout tab in your Command Manager at the top, you're going to select Standard 3 View. It's going to give you a choice of which part. If you only have one part open, you've just got one choice. It's probably already highlighted blue, and then you can hit your green check. It's going to bring in your 3 views, how it, at the scale that it's suggesting for the sheet size that you've got. Now, you can change that, and you probably will. The other part is that you need to be choosing sheet sizes that make sense for your part. We're going to stick to a lot of like ANSI size A and B. Those are pretty safe bets for this course, but it is going to take a guess at your size. So now automatically I've got those 3 orthographic projections, my 3 standard views. You can see that the origin, it's highlighted in blue there. If you wanted that to go away, if it was bothering you visually, if you'll go to that little eyeball, you can either click the whole eyeball off and then it won't show any of the things, or you can go into that little drop-down menu and click off the origin. So now we're going to create these dimensions. So if you go to model items, you can automatically select to have the entire sheet dimension itself. Here is my caution to you. SolidWorks does an okay job at guessing, but you will probably be better off putting in each dimension one by one. So going back in and doing smart dimension one by one. So neatness and adhering to standards will count. And just selecting the auto dimension, which is essentially this feature, will often not adhere to those standards. So you might as well not have dimensioned it anyway. Because if it's messy, if it's not, if you've got the same part dimensioned in a whole bunch of views, then you're not going to get the points for it anyway. So you might as well just go through and smart dimension one by one. But this feature exists, you're going to find it, and so I'm just trying to get ahead of it and show you, yeah, it does exist, but here are some limitations. So I'm making sure that entire model is selected. I'm importing it into all the views. You'd be really better off if you'd go down and click to not include it at the dimensions placed in the drawing, but it's fine. But this is my point exactly. So do you see how, let's go back to this video, they've come in like very far away from the part. You've got these crossing dimension lines. We're going to get more into some of these rules, but it's just messy in general. So it's really not the best way. Yeah, I stick by that statement. So you can go in and rearrange those. You can click and drag them. You could delete them and then add more later. You can do all kinds of things. And so maybe you want to do that. Maybe you are going to go in and let it auto dimension and then rearrange them. But if you don't rearrange them, then you're not going to get the points for it. So what I'm suggesting, I guess, maybe I don't have a video of this, is that you just go into Smart Dimension. If you'll click Smart Dimension, you can dimension your part just like you do in those part files. So you'll click a line or 2 points or a curve, and you'll add dimensions one by one. If you want to change the title block, so the title block is this down here, or maybe you'll have like a note that you'll put to the side. You'll do that in this edit sheet format. So right click on an empty portion. You can select edit sheet format. You can also do that by going to the sheet format tab and selecting edit sheet format. But now that text in the title block you're able to edit it. So a double click and you'll be able to get into some of those already set boxes. Your textbook does a really nice job of walking you through adding text boxes, editing them, and part of your first homework problem, it'll have you adjust the title block. So we're going to switch gears a little bit and move to dimensioning. Kind of a natural transition. Now that you know how to bring these part drawings in, let's think about how we want to communicate our ideas. So why does it matter, and what are my expectations of you from a grading perspective? So especially since we are not in class today, I really, really think it's important that you read those first 8 pages. It's in your hand-drawn sketchbook, you know, before you get to the section where you're drawing. There's that text for it. It's going to be crucial that you're reading those 8 pages this time, especially if you've not done something like this before. So let's just get some quick terminology out of the way. The dimension, it's that numerical value. So it's that number that's telling you the size of your object or feature. Dimension lines, they're these little like extensions that come from the number. It's not extensions because extension lines are their own thing. So it's coming off of your object. So they're thin. You can see they're lighter than our object lines here. Leader line, you're going to use that for, well, most of the time you'll be using it for like a radius or diameter, some curvature of features. One thing to note is that the arrow, it points through the center of the circular feature. And that's an important part about leader lines. And then arrowheads are just, they can be either inside or outside those dimension lines and extension lines, but they're showing you where that dimension goes to. So in general, what you want to do is communicate all the information, but without redundancies. So based on, you know, so in this, if this is my front view here, if I was to look at this part in a top view, I know that I'd be able to see this distinction here, like this 24 and 30 unit distinction. And so I would only dimension it in one of the views. I'm not going to, in your hand-drawn stuff, I'm not going to go crazy with the dimension lines being 3/8 inch from object, that sort of thing. But one thing I am going to be little obsessive about is that there is a visible gap between the object line and the start of the extension line. So you can see that gap. Now, there's not a gap if you've got a leader line like this here. So do note that. But otherwise, I will expect, and it doesn't have to be exactly 1/8 of an inch, though you might measure it so that you get a nice sense of that, but I will expect to see it as a full gap. So part of not over-dimensioning your parts is, what they're saying is wrong here, is that you wouldn't do a continuous dimension because you would likely give the overall. So then you would give 12, 15, and the overall, and then you yourself, you can math it out that should be 9. Same here. So the overall dimension provides the missing measurement. And again, these part drawings and dimensioning these parts is all about giving all the information, but stopping there and not giving more information than needed. One of the things your textbook talks about is dimensioning to the L's and not the T's. And so the purpose of that statement is to help you understand how that you want to dimension where the feature is most visible. So they're saying in this example, this would be the T, and this is the L. So dimension to the L's, not the T's. So in short, dimensioning where the feature is the most visible. Your textbook's going to go through quite a few rules with you in those 8 pages, but here are 8 that I really want you to focus on. So each feature is dimensioned once and only once. It should be the dimensions should be attached to the most descriptive feature, so the L's, not the T's. You do make assumptions though, so we make some assumptions about symmetry. If it's a right angle, we assume that it's 90 degrees. We don't need to say that. Dimensions should be outside the boundaries of an object whenever possible. So I've got an example of that. So you would not put it inside the object if you can. You would put it outside the boundaries of the object. Dimension lines should be aligned and grouped to promote a uniform appearance. Dimension lines should be unbroken except for the number between the arrowheads. There should be a visible gap between the object and the origin of the extension line. So yeah, like note that. And then avoid dimensioning to hidden lines when possible. You can almost always not dimension to hidden lines. But there are also, so avoid it. The truth is that we're going to break some of these rules sometimes, but we're going to be really cognizant of when we do that. And so to know how to make good choices about it, first you've got to just like follow the rules kind of blindly, and then we can get into some of the nuance. So to start with, yeah, I just want you to follow the rules pretty explicitly. So remember, what's incorrect about this one is that we've got the overly dimensioned, right? I mean, I can take away either of these, and because I've got the overall, which I would want, I've got too many dimensions, and so it's more correct to have it be this one to this feature, dimensioning to the L, and then the overall. Do it to the most descriptive view. So again, the L's, not the T's. That's what we're saying here. Your overall, your textbook will get into this, but your overall length needs to go between the two views. So front, top, right. Notice that my overall, instead of placing it here, I've placed this overall dimension between these views because it applies to both of these views. And so it's easier to see that, yes, I already know this dimension. Same here. So instead of posting the overall up here, I've posted the overall dimension between the top and the front view. So you can see really clearly how it applies to that top view. Now we're going to get into some new tools for this week. So there's a couple things that I'd like you to learn, especially like construction lines I think will be useful. And then you'll have to use mirror, fillet, and I think you have to do a linear pattern in your homework, but a circular pattern for your in-class assignment, which is not in class, but you get it. Okay, so construction lines are really handy if you need something that maybe you're going to like base a dimension off of it, or it allows you to have this line, this way to make this mark, but it's not going to be something that you would extrude from necessarily. So in this video, I create this whole shape with, and I'm going to go in and dimension it. I'm going to get it fully defined, and then I'm going to change this line to a construction line. So you can do it either way. You can, once you've drawn just like your regular object line, you can go and change it to a construction line, or you can just start with it as a construction line, either way. All right, so now I'm going to right click on this line, and I'm going to switch it to construction. And you'll see now you've got this like dashed line here indicating that it is not an object line, it's a construction line. And the reason I'm doing it in this example, we're going to go to mirror, and I don't need something in between these 2 points. I just need something to mirror this kind of general shape about. So I'm going to start a new part and show you sketch. So I could come down and I could like start my center line or my construction line like that. So I could draw the part or the line initially as a construction line, or I could have it be an object line. Oops. Went over a little bit. Let's trim it. And then go back in, right clicking, and then changing it to a construction line. So it might seem a tiny bit vague why you would want that. I think that they're pretty useful when you're trying to dimension. And in fact, we're going to show you, well, here, let's just show it to you early. So this is your in-class example. So here I've got drawn a construction line here because there's not a reason for that line to exist. You know, it's not part of the feature, but it's helping to show that angle there. So that's why I would make, oops, I'm getting a call, which is kind of weird. I wonder if you could hear that on the video.